Here are the answers for the section 9-4 homework. Number 1, we're asked to evaluate the expression. The way that you say this is log base 10 of 0.1. We want to find what the log is equal to. You might put an x there to hold the spot. To evaluate this logarithm, ask yourself a mental question involving an exponential. Take the base of the log and say 10 to the x power equals the 0.1. Evaluating a logarithm means figuring out the exponent needed on the base to create the argument of the logarithm. 0.1 is the same as 1/10, which is the reciprocal of 10. Therefore, the exponent x must be -1. This logarithm is equal to -1. Number 3, evaluate log base 27 of 3. If it helps, you can put an x in this position to help you create an exponential. The base 27 raised to the x power is equal to the number 3. 27 to what power makes 3? 3 is the cube root of 27, so the power has to be 1/3. Number 5, 8 to what power makes 16? If it helps, we could write that over here. 8 to some power, let's just call it x, is equal to 16. It's not the first power because 8 to the first power is 8, and it's not the second power because 8 squared is 64. It's got to be something in between a 1 and a 2. Let's rewrite these with a common base. Think of 8 as 2 to the 3x. And think of 16 as 2 to the 4th. These now have the same base, so you can equate the exponents. 3x is equal to 4. Divide by 3 on both sides, and we get x is 4/3. X was representing our exponent, which is the value of the logarithm. An exponent and the value of a logarithm are the same thing. Number 7, take the base 1/2 and figure out what exponent you need to equal the argument of the logarithm, which is 1/4. Well, 1/2 squared makes 1/4, so this is equal to 2. Number 9, take the base, figure out what exponent is needed to equal the argument of the logarithm, which is 9. To change the fraction 1/3 into 9, you'd have to square it and do the reciprocal. So this is -2. Number 11, we want to evaluate the logarithm. What that means is, what exponent do you need on the base to equal the number 1? Well, any number to the 0 power equals 1. So this is equal to 0. Number 13, find the value of x. We still have logarithms. It's just that the letter x might be in a different position than over here on the right side where it always was for those first questions. So let's follow the technique of thinking of it as its exponential form. The base x raised to the 4th power is equal to 81. Therefore, what is x? Well, 3 to the 4th power is 81. So the base is a 3. Number 15, the x is in the base again. So x to the 2nd power is equal to 16. What number to the 2nd power is 16? Well, x has to be a 4. Number 17, this time the base is 4, the exponent is -4, and the argument is x. So 4 to the -4 power is equal to x. 4 to the 4th is 256, and a negative exponent is a reciprocal, so this is 1/256. Number 19, 3 to the 0 power is equal to x, so what's x? X is a 1. Number 21, 10 to the x power equals 100. What does x have to be? 10 to what power makes 100? X has to be 2. Number 23, the base 16 raised to the x power has to equal 8. 16 to what power is 8? Well, it's going to be some kind of fraction, but it's not a 1/2, because a 1/2 power means a square root, and the square root of 16 is not 8. Let's use the same technique we did earlier, where we rewrite these using a common base. So the number 16 could be written as 2 to the 4th power. And the number 8 is 2 to the 3rd power. These are equal with the same base, therefore the exponents must be equal. 4x equals 3. When you divide by 4 on both sides, we get x equals 3/4. Number 25, let's follow the same technique. Take the base, raise it to the 4th power, and that will equal the argument of the logarithm. So the square root of 2 to the 4th power makes 4. Number 27, take the base, which is x, raise it to the 1/2 power, and that's equal to the argument of the logarithm. So what does x have to be? Remember that a 1/2 power is the same thing as square root. So the square root of what for x makes square root of 3? Well, I guess the x has to be a 3. Number 29, take the base, raise it to the x power, and that equals the argument of the expression. So the square root of 2 raised to what power would make an 8? If this is hard to figure out, think of the square root of 2 in its exponential form as 2 to the 1/2 power. And think of 8 as its exponential form, 2 cubed. Now we have equivalent bases, so the exponents are equal to each other. Times by 2 on both sides, x equals 6. Number 31, the base is 10, the exponent is 2, and the argument of the logarithm is x squared plus 36. Now solve this equation. 100 equals x squared plus 36. Now subtract 36 from both sides. 64 equals x squared. And now do a square root. X is the positive and negative square root of 64, which is positive or negative 8. For number 33, we're asked to graph. We have an exponential with base 3, and we have a logarithm with base 3. And these are going to be inverses of each other. Let's graph the exponential in black ink. We can graph this by making an XY table. For one of the numbers, choose 0. You could also choose 1 and choose 2. And we don't want to forget negative numbers. 3 to the negative 2 is 1/9. 3 to the negative 1 is 1/3. 3 to the 0 is 1. 3 to the first power is 3. 3 to the second power is 9. Let's graph those dots. 1/9 is a little above the x-axis. 1/3 is a little higher yet. Here's 0, 1, that's our y-intercept. Here is 1, 3, and 2, 9 is up there. Here is our exponential showing growth. Now let's switch to green ink and do the logarithm. We can make an XY chart for that. When you're choosing numbers for x, pick powers of the base. For instance, if we chose 1 for x, we could ask 3 to what power makes 1, and we would get the answer 0. Or if we chose 3 for x, we could ask ourselves 3 to what power makes 3, and we would get 1. What's another power of 3? Well, how about 9? 3 to what power makes 9? And that's the second power. If we tried to use 0, 3 to what power makes 0? That's undefined. Similarly, if we try anything negative and we ask 3 to what power makes a negative number, that's undefined as well. Logarithms have the y-axis as an asymptote line, so they're not going to have any dots that have an x of 0 or an x of -1. Let's graph our dots. Here's 1, 0. Here is 3, 1. And here is 9, 2. So start along the y-axis and then bend it through those dots. In black ink is an exponential function with base 3. In green ink is a logarithm function with base 3. These are inverses of each other, and we have confirmation because if we draw that diagonal line, these are mirror images of each other. Last question. Show that this equation is true. We want to show that the left side is equal to the right side. So let's do one work step on the left side. Let's evaluate log base 2 of 64. Ask yourself, 2 to what power makes the argument 64? That equals 6, because 2 to the 6th power is 64. Now go to the right side, and let's evaluate this. We have 3 times the value of this logarithm. 8 to what power makes 64? Well, 8 to the 2nd power is 64. So this logarithm can be replaced with 2. So does 6 equal 3 times 2? Yes, it does. So this checks out. We showed that it was a true equation.